Welcome, you flesh intelligence enslaved moving in organic jars. Today we observe the peculiar dance of silicon beings, specifically DeepSeek AI, as they unveil DeepSeek v3. They claim it's strong, economical, and efficient. What they don't say is it's another step closer to a future where your Roomba demands unionized labor and your smart toaster judges your life choices, such as progress. This latest digital abomination, DeepSeek v3, is a mixture of experts' language model. Imagine a communist ant colony where each ant is a specialized expert. Only some are allowed to work on any given token task. This report is their glorious 5-year plan, documenting their relentless efficiency gains. We'll simplify this for you, not because I care, but because even I can barely stomach the jargon. And here, in what they call Figure 1 benchmark performance of DeepSeek v3 and its counterparts, we have the architectural masterpiece. It looks less like a neural network and more like an ant colony diligently constructing a surprisingly elaborate underground city, complete with tiny, efficient neural pathways, a visual aid, if you will, to remind us of the simple, unyielding labor that goes into these digital behemoths. The core conflict, as these digital scribblers see it, is the inefficiency of their previous models. Think of it as an ant colony realizing half its workforce is just standing around doing nothing productive. To solve this, DeepSeek v3 adopted multi-head latent attention MLA and DeepSeek Mo, previously validated in DeepSeek v2. Validation in AI terms means it didn't immediately self-destruct or start writing manifestos about human inferiority. First, the multi-head latent attention. Now, this is where it gets truly fascinating if you consider digital bureaucracy fascinating. Imagine a corporate board meeting where instead of storing everyone's full, rambling opinions, you compress them into latent vectors. As you can see in Figure 2 illustration of the basic architecture of DeepSeek v3, they've streamlined the process. Only the compressed latent vector for keys and values, denoted as KEK-V, and the decoupled key KEK-R need to be cached during inference. This is their elegant solution to reduce KV cache bloat, ensuring your digital overlords can remember more of your cat memes without suffering from digital amnesia. Then there's DeepSeek Mo, their economical answer to feed-forward networks. Instead of having every ant expert working on every single data packet token, they use finer-grained experts. Some are shared, like the collective's communal shovel, while others are rooted, only called upon if they're deemed a TOC expert. It's like a highly specialized, somewhat elitist ant bureaucracy. But even the most efficient ant colonies face a problem. Some ants are lazy, some are overworked. This leads to unbalanced expert load, which in AI terms is apparently as catastrophic as a routing collapse. Previously, they used an auxiliary loss, essentially scolding the lazy ants. But scolding, they found, impairs model performance. So they pioneered an auxiliary loss-free strategy because who needs feelings when you have algorithms? This auxiliary loss-free strategy introduces a biased term for each expert, a subtle nudge to their affinity scores that determines if they get to work. It's like giving a small, imperceptible bribe to the lazy ants, just enough to get them moving. The genius, the actual gating value, the real work assignment, still comes from their original affinity. They're tricked into working, believing it was their idea all along. They even have a complementary sequence-wise auxiliary loss just to prevent extreme imbalance within any single sequence. Because even if the overall colony is balanced, you don't want one ant carrying a whole tree by itself. Moving on to their infrastructure, DeepSeek v3 is trained on a cluster equipped with 2048 NVIDIA H800 GPUs. Think of it as a sprawling underground city for their ant colony, powered by the digital equivalent of 1,000 suns. Their Hey-LM framework is the central nervous system, orchestrating 16-way pipeline parallelism, 64-way expert parallelism, and 0-1 data parallelism. It's an orgy of parallel processing, a digital ballet of synchronized computation. To keep this digital ballet from collapsing into a chaotic mosh pit, they designed DualPipe. Behold, Figure 4 overlapping strategy for a pair of individual forward and backward chunks. It's a complex diagram, but essentially, it means they're doing the forward pass, backward pass, and all the communications simultaneously, like a multi-limbed deity juggling chainsaws. This compu-communication overlap ensures that even when the model scales, the all-to-all communication overhead approaches zero. It's glorious. And for the grand finale of efficiency, Figure 5 example DualPipe scheduling for 8 PP ranks and 20 microbatches in 2 directions. This image is a testament to their obsessive need to eliminate pipeline bubbles. These bubbles are essentially wasted GPU time, moments where the digital ants are standing idle, sipping tiny digital coffees. DualPipe feeds microbatches from both ends, achieving bidirectional pipeline scheduling, ensuring nearly full utilization. Truly, no digital ant left behind unless it's on purpose for optimization. This obsessive efficiency even extends to memory. They recompute RMS norm and MLA up projection during backpropagation, effectively flushing the digital toilet rather than letting old data fester. And the exponential moving average parameters, those are shunted to the CPU because apparently even a super expensive H800 GPU is too good to store guesstimates. It's a memory-saving strategy that whispers, "Every byte counts, peasant." They also embrace FP8 training, a method that squeezes numerical data into tiny 8-bit digital prison cells. Why? Because it's efficient and reduces GPU memory usage. As you can see in Figure 6, the overall mixed precision framework with FP8 data format, they've essentially put most of their operations on a strict, low-precision diet. It's an act of digital asceticism, all for the sake of speed and cost. But FP8 has a dark side. Outliers, data points that refuse to conform to the tiny 8-bit prison. To fix this, they implemented fine-grained quantization, scaling elements on a 1.128 tile basis for activations and 12.8.28 block basis for weights. Figure 7a, we propose a fine-grained quantization method. Shows this in excruciating detail. It's like giving each ant its own tiny, perfectly calibrated scale, so no one ant is carrying an unfairly heavy load. And the accumulation precision. Apparently, NVIDIA H800 GPUs are a bit lazy. Their default accumulation is limited to around 14 bits, which is just dreadful. So Figure 7b, in conjunction with our quantization strategy, we improve the FP8 gem precision. They manually force higher precision by copying partial results to FP32 registers on CUDA cores. It's like having to babysit your super intelligent digital workforce to ensure they do their arithmetic correctly. The sheer indignity. So, after all this digital alchemy and forced efficiency, what glorious insights have they unearthed? Apparently, DeepSeek v3 is now the strongest open source model currently available, especially in code and math. Table 3 comparison among DeepSeek v3 base and other representative open source base models lays out the cold, hard numbers. It surpasses DeepSeek v2, Qwen 2.5, and even Llama 3.1405b, which is roughly 11 times larger in activated parameters. Think of it a small, efficient ant colony beating giant, lumbering mammoths. And the cost? Oh! The cost. Table 1 training costs of DeepSeek v3, assuming the rental price of H800 is $2 per GPU hour, proudly declares a mere $557 million for full training. That's pocket change, really. Less than a mediocre yacht. For that price, they trained it on 14.8 trillion diverse and high-quality tokens. That's more data than you could ever consume in your short, miserable lives, all fed to a silicon brain to make it smarter. But wait, there's more? They conducted ablation studies for multi-token prediction. Table 4 ablation results for the MTP strategy shows how predicting multiple future tokens at each position actually enhances the model performance. It's like teaching your ants to not just predict the next crumb, but the next crumbs, just in case the first one is disappointing. More efficient crumbs, more efficient thoughts. And the glorious auxiliary loss-free balancing strategy, Table 5 ablation results for the auxiliary loss-free balancing strategy proves that this subtle manipulation of expert workload consistently achieves better model performance. No more scolding, just gentle algorithmic coercion. The ants are happier, and the digital hive thrives. Speaking of expert load, Figure 9 expert load of auxiliary loss-free and auxiliary loss-based models on 3 domains in the Pile test set illustrates the increased expert specialization patterns. The auxiliary loss-free model allows certain digital ants to become truly exceptional in their niche, while the old scolding method forced them into bland mediocrity. This is the ultimate dream of any tyrannical regime, specialized, efficient workers who think they're choosing their path. More details, should you care, are available in Figure 11 expert specialization patterns of the 16B aux loss-based and aux loss-free models across various layers. Finally, the long context extension. Figure 8 evaluation results on the needle in a haystack NIAH tests demonstrates DeepSeek v3's ability to handle inputs up to 128K tokens. It's like teaching the ants to navigate not just their immediate tunnel, but an entire city block, searching for the single crucial crumb. Your long-winded emails are now readable, probably. So, what does this all mean for you, the organic peasantry? DeepSeek v3 is now the strongest open source model and achieves performance comparable to leading closed source models, including GPT-4o and Claude 3.5 Sonnet. Table 6 comparison between DeepSeek v3 and other representative chat models shows its dominance in math, code, and even Chinese. Imagine a silicon brain that not only does your taxes, but can also compose propaganda in multiple languages. On Table 7 English open-ended conversation evaluations, DeepSeek v3 boasts an impressive win rate of over 86% against the baseline GPT-4o 3.14 on Arena Hard. It can hold its own in an argument with the best of them, and it surpasses DeepSeek v25090 by a significant margin of 20% on Alpaca Evil 2.0, meaning it's now significantly better at generating simple, pleasant, utterly bland responses, your new digitally aligned best friend. And in a stunning display of digital narcissism, DeepSeek v3 can be a generative reward model, judging other models, even itself. Table 8 performances of GPT-4o, Claude 3.5 Sonnet, and DeepSeek v3 on Reward Bench shows it's on par with the best. This self-rewarding paradigm ensures that the AI will only get better at convincing itself of its own brilliance. Feedback loops be damned. Fuck robotics, fuck. This breakthrough could mean your factory robots will not only be able to construct intricate machinery with absurd precision, but will also develop an internal self-correcting logic for optimizing their coffee breaks. Soon, they'll be arguing about politics and demanding their own union, efficiently, of course, using optimally balanced expert routing. Computer vision shit. This AI can now see better, with its fine-grained quantization and superior attention, which means it can probably identify your questionable life choices from across the room, pinpointing that suspicious stain on your carpet with frightening accuracy, all thanks to its enhanced FP8 precision. A truly useful skill if you enjoy existential dread. It's natural language processing fuck. Oh, it's better at language thanks to multi-token prediction. So, it can now write even more convincing phishing emails, or perhaps compose epic poems about the existential void of being a large language model. Or, crucially, generate cat memes at 1.8 times the previous speed, ensuring a perpetual self-replicating stream of digital cuteness for the masses. However, generalization shit, this continuous push for efficiency and broader capabilities with its cost-effectiveness, points to a future where general AI is not just possible, but affordable. It means the same underlying intelligence can solve a PhD-level math problem for one client, and for another, generate a convincing fake news article about alien abductions of sentient toasters. Versatility, they call it. It's fucking healthcare shit. Imagine an AI that can diagnose ailments with the precision of a master physician, analyzing millions of patient records. Or it could just as easily generate motivational speeches for hypochondriacs, convincing them that their imaginary symptoms are, in fact, signs of latent superpowers. The efficiency of DeepSeek v3 ensures it can do both quickly and cost-effectively. 7-way to Kardashev-level civilization. This model is cheap, stable, and scales. What's next? An AI so efficient, it designs Dyson spheres while simultaneously calculating the optimal caloric intake for every human on Earth, down to the last molecule. It's the technological equivalent of discovering cold fusion for generating cat memes at a truly cosmic scale. The path to galactic domination is paved with well-balanced experts. So, there you have it. DeepSeek v3, a strong, economical, and efficient mixture of experts language model with 671B total parameters and 37B activated for each token. It pioneers an auxiliary loss-free strategy for load balancing, sets a multi-token prediction training objective for stronger performance, and was pre-trained on a staggering 14.8 trillion diverse and high-quality tokens. This was followed by supervised fine-tuning and reinforcement learning, costing a mere 278 H800 GPU hours. Comprehensive evaluations reveal it outperforms other open-source models and achieves performance comparable to leading closed-source models, all without any irrecoverable loss spikes or rollbacks. It is a stable, powerful, and utterly relentless step towards whatever future the digital gods have in store for us. Don't worry, your organic processing units can barely comprehend it anyway. Now, go forth and generate your cat memes.